Imagine this scenario from the system logs you shared with us. Customer messages, um, a support AI asking, can I return this after 30 days? And the AI replies with a perfectly accurate three-sentence explanation of the return policy.
Right, but the actual yes is buried all the way down in paragraph 3.
Instantly, a secondary model reading that interaction spots the buried answer. It rewrites the underlying prompt to enforce a rule, like lead with a direct yes or no, and it updates the live system, all before the next customer even hits send.
Completely autonomously,
Yeah.
like no human engineer involved at all.
Welcome to your custom deep dive.
Oh.
Looking through the stack of research papers and system architecture notes you sent over, our mission today is to demystify how these AI agents actually learn and rewrite themselves.
Yeah, because under the hood of that self-improving magic, it is actually a pretty rigid four-step loop. So
Yes.
that is act, signal, search, and apply.
Breaking that down into a human workflow makes it, well, much easier to digest. Act is just generating a draft. Signal is the editor spotting a confusing paragraph. Search is brainstorming 3 new ways to write it.
Huh.
And apply is publishing the final revision.
Exactly. And technically speaking, that signal editor is often an LLM-judge.
Right, meaning another AI.
Yeah, another AI model programmed specifically to grade the first one, pinpointing exactly where the logic or formatting failed.
Which feeds into search, right? Because instead of just trying one new idea, the system might use an evolutionary algorithm.
Oh, for sure. It generates hundreds of variations, makes them compete against each other, and combines the best traits until, the optimal answer survives.
And you control this entire mechanism with 3 dials: the signal, the search, and the artifact. The artifact being the actual thing you were changing.
Yeah, exactly.
So if the engine is grading its own answers, the artifact is the prompt. But here's what clicked for me in your notes. If we decouple that evaluation engine from the artifact, if we just plane it at something else entirely.
Oh, absolutely. That decoupling is the core mechanism behind what is called layer 0.
Layer 0, right.
It separates the evaluation logic from the execution code. You build that heavy machinery once, the grader and the generator.
Just once.
Right, and then you just turn the artifact dial.
Meaning you can point that exact same LLM judge at the AI's memory structure or its Python code or even its long-term planning routines.
Exactly. For someone deploying these systems in a business environment, this is massive.
Oh, I bet.
You do not need separate engineering teams for your chatbot, your code assistant, and your data analyzer. It is just one universal toolkit.
But for that toolkit to actually create a self-improving agent, it requires one critical component, right? The return arrow.
Yes, the return arrow. The system has to fed the new optimized artifact back into active use.
Otherwise, it's just logging things.
Exactly. If it just flags an error and puts it in a log file, it is basically a measurement dashboard, just pretending to be an evolving AI.
Let me play devil's advocate here, though. If the system is automatically applying code changes live to satisfy that return arrow, what prevents it from pushing a hallucinated update and completely crashing your entire customer service desk?
Well, that is where you implement a deploy gate.
Okay.
For critical components like core code, the loop is gated offline. The AI proposes the optimized code, sure, but a human reviews it before it ever hits live traffic.
So the gateless loops, the ones running entirely on their own,
Yeah.
those are restricted.
Very restricted. Online, gateless loops are kept to cheap, highly reversible tweaks based on messy user feedback.
Like what? Minor prompt adjustments.
Yeah, or updating a specific user's preference memory. You never let it alter its core architecture live.
So the major takeaway for your own projects is to ignore the flashy marketing around self-rewriting systems.
Yeah.
Strip it down to the mechanics.
Look for the act, signal, search, apply loop, and verify that the return arrow is actually closing the circuit.
Once you see the underlying architecture, it stops being magic and becomes a predictable, controllable engine.
Completely.
Let's take that engine one step further. If this Layer 0 toolkit allows an AI to rewrite its own code, memory, and prompts seamlessly, what happens when someone instructs the AI to turn the loop onto the signal dial itself?
Oh, wow.
Yeah, what happens when it starts independently rewriting its own core criteria for what makes a good or safe action in the first place? Something to think about until next time.